Science is the interdisciplinary study of the mind and how it processes information. It explores how people perceive, think, learn, remember, and use language. Cognitive science combines knowledge and methods from several fields, including psychology for understanding mental processes and behavior, neuroscience for studying the brain's structure and function, linguistics for examining how language is understood and produced, computer science and AI for modeling human thinking and building intelligent systems, philosophy for exploring the nature of knowledge, mind, and consciousness, anthropology for looking at how cognition varies across cultures, education for applying cognitive principles to teaching and learning. It aims to answer questions like, how do we solve problems? How is knowledge represented in the brain? Can machines think like humans? Would you like to know how it connects to a specific field, like education or AI? In education, cognitive science plays a key role in understanding how students learn and how teaching can be made more effective. Here are some ways cognitive science informs educational practice. 1. How memory works. Cognitive science has revealed that spaced repetition, retrieval practice, and elaboration improve long-term memory. Teachers can design lessons that help students retain and recall information more effectively. 2. Cognitive load theory. This theory explains that the brain can only handle a limited amount of information at once. Educators use this to avoid overloading students with too much content or unnecessary distractions, especially when introducing new topics. 3. Metacognition. Teaching students how to think about their own thinking. Metacognition helps them become more independent learners. Cognitive science supports using reflection, planning, and self-monitoring strategies in the classroom. 4. Understanding misconceptions. Cognitive scientists study how students form incorrect ideas and how to correct them. Teachers can better anticipate and address common misunderstandings in subjects like math and science. 5. Learning differences. Insights from cognitive science help educators tailor teaching methods for students with dyslexia, ADHD, autism, and other learning difficulties. 6. Motivation and attention. Research in this field helps identify what keeps students engaged and how to structure tasks to maintain focus. 7. Use of technology. Educational technology is often based on cognitive principles, such as adaptive learning systems that adjust difficulty based on a learner's performance. In short, cognitive science helps educators understand how learning happens and guides them to create evidence-based strategies that support all learners. Would you like an example of a teaching method based on cognitive science? Here's an example of a cognitive science-based teaching method tailored to college-level math students in the UK. Example, using retrieval practice and spaced repetition in A-level or further education maths. Topic, solving quadratic equations. Cognitive science principles. 1. Retrieval practice. Actively recalling information strengthens memory more than rereading. 2. Spaced repetition. Spreading out practice over time improves long-term retention. 3. Interleaving. Mixing different types of problems helps students learn to choose appropriate strategies. Teaching strategy. Week 1. Introduction and initial practice. Teach how to solve quadratics by factorization, completing the square and using the quadratic formula. Students do worked examples, followed by practice problems in class. Week 2. Retrieval practice. Start the lesson with a 5-minute do now activity, e.g. solve x2 plus 5x plus 6 equals 0, factorization. Rewrite x squared minus 4x plus 7 in completed square form. This forces recall without notes. Week 3, spaced practice. Revisit quadratic equations in warm-ups or homework. Mix in with newer topics, e.g. graphs of quadratics or simultaneous equations. E.g., which method would you use to solve 2x squared plus 3x equals 2? Explain why. Week 4, interleave practice. Give a mixed set of problems. Some quadratics to solve, some linear equations, some inequalities. Students must identify the type and choose the correct method. This builds decision-making skills and deeper understanding. Why this works: forces retrieval, stronger memory traces, space between practice, reduces forgetting. Mixing types of problems improves flexible thinking. Would you like a printable activity sheet using this method? Boredom is one of the key triggers for low engagement and disruptive behavior in classrooms, especially in maths. Cognitive science offers several evidence-informed strategies to maintain motivation, focus, and behavior, particularly for learners who struggle with self-regulation. Here's how you can apply cognitive science in practice to reduce boredom and increase engagement. 1. Use desirable difficulty. Cognitive science shows that students are more engaged when tasks are challenging but achievable. If a task is too easy, boredom. If it's too hard, anxiety and disengagement. How to apply: give tasks with scaffolded support. Use differentiation so students at different levels feel challenged. For example, while revising linear equations, set 3 tiers of challenge and let students choose or rotate. 2. Chunk tasks and use attention resets. Our attention span is limited, around 10 to 15 minutes for many learners. Cognitive load theory shows that long, uninterrupted input can overwhelm working memory. How to apply: break lessons into 10 to 15 min chunks, e.g. instruction, guided practice, paired problems. Use attention resets, short transitions like a quiz, a whiteboard question, or peer discussion. Retrieval games and low-stakes quizzes. Retrieval practice boosts learning, and turning it into a game boosts engagement too. How to apply: use mini whiteboard races, Kahoot quizzes, or last person standing with mental maths. Build in fun and pace to revision. 4. Give students choice. Autonomy support. Self-determination theory, a cognitive motivational framework, says autonomy increases motivation. How to apply: let students choose which order to complete tasks, which topic to review today, which method to use to solve a problem where appropriate. 5. Make learning purposeful and relevant. Cognitive science supports connecting new content to students' prior knowledge and real-world goals. How to apply: link maths problems to real-life contexts, e.g. percentages in shopping, statistics in sports. Use career links, e.g. this type of algebra is used in engineering and design. 6. Use social interaction. Peer learning. Learning is more engaging when it's interactive. Vygotsky's social constructivism shows that working with peers supports understanding. How to apply: think, pair, share. You're the teacher tasks. One student explains, one listens and gives feedback. 7. Catch misbehavior early with preemptive structure. Bored students can become disruptive. Cognitive science supports clear routines and transitions. How to apply: establish clear behavior expectations and signals. Use timers, visible task lists, and routines for transitions to reduce downtime. Summary table: cognitive principle, strategy example, purpose, turkus, to reduce downtime. Desirable difficulty, tiered tasks with scaffolded support. Avoid boredom, easy work. Cognitive load theory, chunked lessons, breaks. Maintain focus. Retrieval practice, games, quizzes with past content, boost memories, fun engagement. Autonomy, student choice in task topic, increase motivation. Schema theory, real-life maths contexts, make learning meaningful. Social constructivism, peer learning's discussion, increase understanding, focus. Behavioral structure, routines, signals, countdowns, minimize downtime, misbehavior. Would you like this in a printable handout or added to your teaching portfolio? Absolutely. These cognitive science strategies are especially important and relevant for GCSE RESIT and Functional Skills Level 1 and 2 learners. Here's why. Hack why it works for GCSE RESITs and Functional Skills. 1. These learners often have low confidence and motivation in maths. They may have previously failed or struggled with maths, so their self-belief is low. Cognitive science shows that small wins, retrieval success, and feeling challenged but capable help rebuild confidence. Use desirable difficulty, retrieval practice, spaced repetition. Why? Builds mastery without overwhelm. 2. They tend to have gaps in understanding and working memory overload. Many functional skills and GCSE RESIT learners struggle with retaining maths procedures, chunking content and reducing cognitive load. Makes learning manageable and reduces frustration. 3. They are easily bored if content feels repetitive or irrelevant. They've often done this before and feel it's not connected to real life. Use real-world contexts, autonomy, games, and peer learning. Why? Increases engagement and helps them see the point of maths. 4. They often lack self-regulation skills. Many learners in this group find it hard to control attention, manage frustration, or stay on task without support. Use routines, clear transitions, attention resets, visual task boards. Why? Structure supports focus and prevents misbehavior. 5. They benefit from interactive and socially supported learning. These learners often respond well to pair work, discussion, and non-threatening questioning. Think, pair, share, teach your partner, mini whiteboard work. Why? Encourages participation without embarrassment. Hack practical examples for your learners. Strategy, GCSE RESIT example, functional skills example. Retrieval practice. Start lesson with mini quiz on BIDMAS. Match percent terms to decimals in warm-up. Spaced practice. Spiral back to fractions during the lesson. Revisit place value each week. Real-life context. Calculate interest on a loan. Use budget planning for groceries and autonomy. Let students choose topic to revise. Choose between calculate and non-calc questions. Peer learning. Pairs solve and explain to each other. Error spotting. Find the mistake and fix it. Game-based learning. Kahoot on algebra terms. Bingo with times tables or conversion facts. Attention resets. Timer for 10-minute bursts. Brain break. How many ways to make 100? Yes, cognitive science strategies are vital for keeping GCSE RESIT and functional skills learners engaged. These students often need structure, confidence building, and relevance more than any other group. Would you like this summarized in a printable classroom strategy sheet or CPD slide?